Hello everyone, welcome back to Mr. Lee's Math Class Videos. I'm Mr. Lee. We're picking up in section 6.3. So the rest of chapter 6 primarily is about graphing all the trig functions and the visual representation of all of them. 6.3 is the basics of graphing with sine and cosine, and 6.4 adds translations to sine and cosine before 6.5 and 6.6 take us through the other trig functions. So really, to establish the baseline, we're going to talk about a few things about sine and cosine and their behavior and what's important on the graph, or where the identifiable components are on a graph of sine and cosine. So recall from 6.2, there are plenty of phenomena that repeat consistently, like tides, hours of daylight, phases of the moon, even your heartbeat. These can all be modeled by periodic behaviors like sine and cosine. So a periodic function is one that f of x equals f of x plus np. All they're really saying is if you add a certain amount to the input value, you'll end up producing the same output. And we know on the unit circle in particular, if we add 2 pi to anything or subtract it, we get the same values for sine and cosine, really any of the trig functions, but we're starting with sine and cosine there. So let's talk about the quadrants and the behavior of sine and cosine as we go through them to get an idea of what's going on. So we know that sine and cosine are always between -1 and 1 just because of their ratios. They're a side of the triangle divided by the hypotenuse. In particular, they'll hit 1s, 0s, and -1s at our quadrantal angles, which are either the 90, 180, 270, and 0, or 0, pi over 2, pi, and 3 pi over 2, and then back to 2 pi would be back to normal. So we're going to do this in terms of radians because it's more appropriate to do this in radians now. So between 0 and pi over 2, sine starts at a y value of 0, and then at pi over 2 it ends up being 1. From pi over 2 to pi, sine starts at 1 and goes back down to 0. Then on the second half, quadrants 3 and 4, it starts at 0 where it ended at pi and goes to -1. And then it recovers from -1 back to 0, and then we're back at the beginning where we start over again. Now what this shows you is that even if we just have the data about 0 through 2 pi just at the 90-degree angles, we hit every maximum, every middle point, and every minimum for sine along the way, which really means that these angles, or the equivalent to them, are the most important parts. Cosine is a little bit different. By the way, this shape ends up, we'll see it on the next page, and the visual shape of cosine as well. Cosine starts at 1, goes to 0 at pi over 2, and then it goes from 0 to -1 from pi over 2 to pi, and then it recovers -1 to 0, and then it goes back from 0 to 1. Now, if you look at these patterns, everything from cosine to sine is really just shifted down 1. They have the same patterns, just how they hit them is a little bit different, like the ordering of how they hit things. So this will be important to note moving forward when we look at their shapes. So on the next page, we're going to graph them and look at some values just to make sure. Now, we'll get approximations for these. I'm going to put the exact answers. So you notice I'll walk you through the first 2 quadrants, and then we'll hit the quadrantals from there and kind of try to draw our own conclusions. So starting with sine. Sine of 0 is 0. Sine of pi over 6 is our 1/2. Sine of pi over 3 is root 3 over 2. Sine of pi over 2 is 1. Now graphing these, 1/2 is 0.5. So sine of 0 is 0. So I'm going to graph this one. I'll graph sine in red. So f of x equals sine x will be graphed in red. So we have 0, 0 as a coordinate point. If we write them over here. We have pi over 6 is our x, 1/2 is our y, pi over 3, root 3 over 2, and then we have the point pi over 2, 1. Just writing them underneath. So we plot those, 0, 0. Pi over 6, which is right here, is at 1/2. This will be the sides 1 and -1. At pi over 3, we're at root 3 over 2, which is about 0.85, so it would be about here. And at pi over 2, you're at 1. So if you look at this behavior, it does look to be doing something like this, which we'll see generally how it does when we finish. So now we're going to go through the second quadrant and do the same thing in the coordinate points. 2 pi over 3, we're back at root 3 over 2. 5 pi over 6, back at 1/2, and at pi, we're back at 0. So looking at these coordinate points, similarly, plotting our x and y, at 2 pi over 3, we're back here, back at 1/2, and then back to 0. And that tells us where we are there. You'll notice going to 3 pi over 2 and then back to 2 pi, it'll be the same through the negatives. At 3 pi over 2, we're down at -1. So it's going to follow the same pattern. We're halfway through here. We're pretty close here. We're up, and the pattern will continue until we're back at 2 pi, which the pattern will start over again. So this gives you an idea of what sine looks like. So on your homework, when you see buttons for graphing, you'll see one that looks like this. This is the sine button. When you see it like that, it's indicating that it wants a sine graph. So now we will do it with cosine, same process, but we'll graph it in a green color. So we've got cosine of 0 is 1, and it's just backwards from this one, root 3 over 2, 1/2, and 0. So same strategy, only it's starting at a different value, a different really place in this pattern. So we're up here at 1, and then we start dropping, same height here. We kind of swap places here, back down to 0. So this looks very similar to this portion. So these 4 look the same as these 4, which is the right side over here. And then cosine continues at 2 pi over 3 into the negatives, so -1/2, negative root 3 over 2, and then back to -1 here. So we've got, again, similar patterns, -1/2, negative root 3 over 2, -1. You'll start to notice this looks a little bit similar. And then cosine of 3 pi over 2 is back to 0. So it's going to recover just like sine did in a similar way. Up to the 1/2 and back to 0. And then from there, it'll have to go back up to 1 because we know the ending point at 2 pi should be the same as the beginning. So it will go through the pattern that sine did at the very beginning before turning around. So this is the high point, so it turns around. So on your homework, when you see the little graph buttons, if you see one that looks like this is the cosine x graph on there. And this is what they look like, and they just keep repeating every 2 pi from there. So the real question is, these are our basic sine and cosine. So what's going to happen when we start introducing, say, numbers inside with x or numbers out front? What's going to happen to our graphs? And we'll learn that in the next video.